I'd like to take a moment to thank the Blockchain Academy. The Blockchain Academy is an educational training firm offering blockchain training to the enterprise. The Blockchain Academy offers courses for both management and developers, offering delivery online and in live classrooms. The Blockchain Academy works with enterprise clients to create and deliver innovative training programs globally. They recently announced a new blockchain course targeted towards attorneys. To learn more about the Blockchain Academy, visit them at www.theblockchainacademy.com.
This is the Blockchain 360 podcast. Blockchain 360 is a podcast of interviews and discussions about the current state and direction of blockchain. Thank you for joining us today. If this is your first time listening, then thank you for coming. The Blockchain 360 podcast is produced weekly for your enjoyment, and show notes are found at our website, blockchain360.co. Come back often and feel free to add the podcast to your favorite RSS feed or iTunes. You can also follow us on Twitter at Blockchain360. All links discussed today are included in the show notes.
Hi, my name is Brian Nielsen, and I'm your host here on Blockchain 360. And today's guest is John Lyotier. And he is an entrepreneur and a successful marketer with more than 20 years of experience in promoting, launching, designing, and jumpstarting new businesses and products through innovative marketing concepts. John Lyotier is in leveraging technology, marketing, and product hacks to bring new ideas to markets. So, John, how is it you came to, well, let's start with this. What is the story behind this company, RightMesh?
Sure, that's a good place to start. So the company itself is a subsidiary of the parent company called Left. Left was formed by myself and my partner Chris Jensen back in 2010. And we were a little bit perverse, so we decided to call the company Left because we wanted to do things right. It wasn't until a few years ago that we actually had a chance to truly understand what that meant. In your early days of most tech companies, you start off with doing what is at a cost, what costs the least, and in that instance for us as two business-focused, technology somewhat centric entrepreneurs, we actually went out to various contractors around the world to help jumpstart some technology projects we had. One of whom happened to be in the country of Bangladesh. Yes, he was cost effective. Yes, he was able to do things quickly. But what quickly happened is that we turned out to be very, very talented. And we really sort of formed a heartfelt relationship with our team in Bangladesh, eventually have formed a team where we now have 60 people over in the country. But
wow.
For RightMesh itself, it really started with the team.
And that's all with Left, right?
That's all with Left. Yep.
Okay.
With RightMesh as a subsidiary corp to it, we have about half of the Left team today working on RightMesh and its projects.
Okay. So tell me more about RightMesh.
So RightMesh really started out of the pain that Bangladesh felt on an everyday basis. The connectivity itself is really, really poor. The infrastructure is overloaded. The power goes out 3 or 4 times a day. And what they started to create many years ago now was this peer-to-peer connectivity platform to let people share and connect without using internet. So that's no internet, no data, no wireless router or infrastructure, just device-to-device to device communication. So they created that a few years ago. We looked at it and said, wow, guys, this is really incredible. We really have something here. And it was a bit of a deviation from our current product lines. We had background in internet technologies and some mobile applications, but this is sort of a brand new invention for anybody. I said, let's explore this. Let's poke the box a little bit. Let's see what we can create here. And that started off us down this wondrous journey that is now RightMesh.
Okay. So I want to go back and understand this. So these self-forming, self-monitoring, peer-to-peer networks, there was connectivity to the internet through that, or there wasn't?
So in the early days, what actually used to happen, we'd be having a teleconference very much like you and I are having today. But in that teleconference, what the developers would have to do is everybody had to hop off the internet because the connectivity, the throughput was so poor, they needed to basically uncongest the networks. So developers being developers, they said, well, why do we need the internet if I'm sitting here, you're sitting there? why can't we just talk back and forth? And really what it amounts to a local area network, a LAN.
Sure.
Our mobile team says, well, what about us? Our computers are these new smartphones we've been programming on. Why can't we just use that? So they built this technology that was software-based, device-to-device communication. So no routers, no hardware, no go-between. It's just your device broadcasts and receives signal, and my device broadcasts and receives signal. And when they do that, they can talk to each other.
Right.
It's the first generation really started off in a almost like a hotspot mode. If your phone goes into hotspot and you can let other
Right.
people
Exactly.
connect through you, it's kind of like that in the first generation. And we put that out into a few different applications, the largest of which came out with about 1 million installs of that technology. But every time we started to go out and talk to those users, they said, well, you have this technology now to connect. What do you think? I said, well, this is great. This is going to change my life. Can I do more hops? And I said, well, what do you mean? Well, rather than just doing from peer to peer or device to device and right next to each other, is it possible for me to communicate over greater distances? Or how might I
Right. Create a chain. Right.
create a chain? It's a lot of the early customers that we were talking to were primarily in educational environments, university campuses, where they didn't have connectivity that spanned the entire campus. I said, well, I think we can do that. So that was the first conversation. We went out and found some really, really smart PhDs in the space of mesh networking and said, this is our challenge. This is what we're trying to build. Is this A, technically possible? And B, what do you think? And Jason, who's our chief networking scientist, we sort of grabbed him right off his PhD and said, this is what we're trying to build. Can we build this? And he thought about it for a while and says, yeah, we can build that. That was 2 years ago. And now we have just launched, as of Monday,
Wow.
our Mesh SDK, which really lets any application either be retrofit to become a decentralized offline mesh connected application, or any new developer to build new applications that are also mesh enabled. And that really is the multi-hop peer-to-peer-to-peer communication protocol that really does span that distance that we were first talking about.
So, what is the distance that you can have between each of these nodes?
So it all depends on the technology on the device itself. But if you sort of take a standard Android version 5.0, we do go back to version 4.0 for Android, which really covers most phones in the world.
Sure.
But if you have your standard Android 5 device with your basic chipset that would be on that device, so broadcasting, receiving Wi-Fi, broadcasting, receiving Wi-Fi direct or Bluetooth, and we use a combination of all those technologies. That's why I mentioned those ones. But if you are using those, each communication spot has a different frequency and distance it can broadcast across. In essence, it works out to be about 100 meters per node distance between it. So for
That's
the
the
Americans,
maximum. Right.
for each node. So if you look at in the American audience, about 300 feet per node.
Okay.
Bluetooth gives you the 100 feet. Wi-Fi direct is a more powerful signal, and therefore you can go out to about that those further distances. Of course, then when you can start chaining those nodes together, you can cover some pretty great distances.
Sure.
We start looking at what would it cover if you were able to chain a series of hotspots together, and what type of density would be required to cover, say, a city of San Francisco. And you need about 5% density in San Francisco, and that covers about 90 to 92% of the city. Of course, in a city like San Francisco, the mesh technologies, unless there's an earthquake, wouldn't have the utility it does in, say, a city like Dhaka, Bangladesh, where you have the equivalent of 100 people in your living room from a density standpoint. So you can
Right.
get much greater coverage in a place that has that urban density that you find in the emerging markets.
Correct. So, let me have you explain again, what is this mesh? Why is it called mesh as a network? I mean, to me, the terminology is important to understand. So, if you could explain that.
Sure. So mesh really is a technology that different people use it to describe different things. Most people understand mesh as a hardware-based mesh router. So you have products like Eero or Gotenna, which is making the rounds and doing some really cool things with their mesh antenna. Those hardware routers do form communication routes between between different nodes. And if you think of it even one abstracted layer higher, the internet itself is a mesh itself. It's just a connection of servers that function around the world and route traffic accordingly.
Right.
In our side, what we actually try to mirror and copy is a large part of that internet architecture, that internet style of communication. So rather than broadcasting out from my device to anybody who's listening nearby, and then have that person broadcast out to anybody who's listening nearby, we don't do that. We have an intelligent routing protocol that we've built that allows the communication to flow from device to device to device according to what we classify as air quote best communication path.
Right.
That might be shortest hop, it might be most efficient route, it might be looking at an individual node's capacity. Maybe they have different technology and spectrum available that they can broadcast out on. We try to use all of that to determine what's the most efficient route to go from point A to point C.
So how does an individual or a group of people actually create this mesh network? I mean, do you have to like enable everything on your phone?
We actually have stripped it down to operate at the kernel level. We don't use the device routing mechanisms. We actually have gone one level deeper than that on a device. It does broadcast out and receive signal. So it does broadcast and receive Wi-Fi and Bluetooth and the like.
Right.
But really what we want users to do is not have to worry about going on and acknowledging every, yes, turn my phone on to pass a message from you to somebody else. That has
Right.
to be all done autonomously. So, but as a user, we really have to sort of step a level back and clarify what RightMesh is. It's not a software application. It's not a great, I now have the RightMesh chat application or I have a RightMesh game. It really is a platform and protocol that lets people take the mesh communication algorithms and put that into their existing applications. So you could be sitting there with an emergency chatting applications that you yourself have built for communication post-earthquake. That communication application would be using our RightMesh protocols to communicate post-earthquake.
Interesting. So it's a network type protocol versus a phone app or a hardware type solution.
Correct. So some people have tried to build mesh before with manipulating the chipset itself. So going out to all
Right.
the hardware manufacturer and says, hey, we want this new chip to be added to your phone. Please do it this way. Some people have said, hey, let's blanket an entire city with a mesh network, but we need to deploy a powerful Wi-Fi router every kilometer of the city. We say, well, that's kind of ridiculous. There's soon to be 6 billion smartphones walking around the planet. Why don't we just use that hardware as our
The
infrastructure?
existing one, right.
Exactly. So that's really
So,
what we do.
okay, so how is it you became involved in this? I mean, you've shared with me and the listeners the basis for why it existed in Bangladesh, and that's where some of your team was initially stationed. So, how is it that you became involved with saying, you know what, this is really something I'd like to pursue?
So how do we do this? That's a interesting story. So myself and Chris, I alluded to him before. We've known each other since the late '90s. We've been doing different startups, both apart and together over the time. And when we formed the parent company Left, as I said, we were trying to do things right, and we didn't really know what we would create. We had some successful internet businesses. We had a few nice exits along the way. But we were sitting there shortly after seeing this first technology that the team in Bangladesh had created. And we said, well, we have our existing business units and they're doing well. They're on a growth trajectory. We had quite a few in the travel tech and ad tech space. But over here, we have this new shiny object. And the shiny object was big. The shiny object was difficult. The shiny object was one of those big, hairy, audacious goals that if you managed to pull it off, it would be both scary and all those emotions that go along with that new venture. So what do we do? And we made a big checklist on one side of all the reasons why we shouldn't do it. And we made a big checklist on the other side. It actually wasn't big. It only had one item on it. It said, if we can pull this off, we can change the world. And that really started the journey down the path. So let's take our existing resources, or take our existing profits, and we have had a profitable entity. Let's take those profits and plow them into seeing if this is possible. We keep on sort of judging our chances of success, and in the early days we say, well, it's a 10% chance of success, and then a few months go by, well, maybe it's a 15% chance of success, and then it goes up and up and up from there, to the point that we're at today, that we've gone out to the markets, we've talked to the customers, we've talked to the users, we've talked to telecom companies, we've talked to various ISPs who were threatened by no means from what we've been able to create. And with all that, we just keep on increasing the chances of success, and those chances really go into when we pull this off, not just no longer an if, but when we pull this off, we will make a lasting impact and lift hundreds of millions of people out of poverty. And that really goes back into that foundational mission of, we want to build something of real and lasting value that changes the world. We didn't know how we were going to do it to start with, but as we sort of came across the technology, and as we saw the potential that it truly could have, first off in emerging markets, but now also here at home, we realized that, you know what, this is where we have to put our time, resources, and passions, and we've been building it ever since.
I'm thinking more about the mesh aspect of it. So, what is the reliability of having this, and doesn't that create like a single point of failure for these kinds of networks? And does that collapse? I mean, do these mesh networks rise and collapse, dynamically?
Yes, exactly the case. So I should clarify something for yourself and for your listeners as well, that when we say that we are connecting people peer to peer to peer, it's not that we want to not have users use the internet. The internet is amazing. I grew up on the internet. My first startup was back in '97, and it was an internet.com success, and then flame, as those things often were. But the internet's amazing, but most people don't have access to the internet. Yet it's not because that the internet is not available in certain markets. It's that the connectivity costs of that internet connection, or the throughput that's available on that connection, they don't exist.
So right, really, the spectrum exists, but not access to the spectrum.
Well, not even spectrum exists. If you look at the Facebook study that looked at the ability to connect and the rights to connectivity, they concluded that 94% of the population is within range of a internet signal. Just most users don't have the capacity, being the cost of capacity, to afford to connect. They also don't see the relevance in connecting. They have smartphones. Most smartphones in emerging markets are that $50 to $100 smartphone, which is within reach of most of the population. But they just have not been able to afford to connect, or have infrastructure that allows them the freedom to connect. But there are people within that population who do. So when you started looking at connectivity, and you start talking about density and failover rates and all those things you started talking about, you have to sort of imagine that if there is a cafe or a web cafe that has a Wi-Fi access point, within 500 meters of that cafe, or sort of that 1,000 to 1,400 feet, you can have people connect through 4, 5, 6 more hops, and now all share that one internet connectivity.
Does that create a cost, though, for that single point?
It does, which is actually when we started to go out to the customers, they say, hey, wow, this is great, but what's in it for me? You want me to share my data? Really? I don't know if I want to do that. I said, no, you can do this. This is wonderful. It's a great technology. You can give access to all your friends and those in the campus. I said, yeah, I don't know if I really feel so, which really sort of propelled us down into the whole blockchain and cryptocurrency world, because all these people now wanted to say, well, what's in it for me? And we're now able to say, well, we can actually incentivize you with tokens in order to actually give up your data. We sort of look at that as the Airbnb for data, or the Uber for data.
So basically, you're doing micropayments for sharing that bandwidth.
Absolutely. So if you think of your device today, your device sits there with various things on it. It has access to connectivity. It has device resources. It has sensor data. It has a whole bunch of things that, for lack of a better term, could be classified as work. And that work, you should be compensated should you be willing to give up that data to somebody else. So if you are
Right.
going to give up your internet connectivity to somebody else, we can now facilitate that micropayment for you for that data that you give up. Maybe you have free connectivity. Maybe you have a data plan that has a hard cap and it's approaching the end of the month and you don't think you'll be using that extra 1 gig of data. As a sharing economy, just as you are able to rent out your room in Airbnb, you can now sort of sell that excess capacity you have on your device, or that sensor data, or that device storage and capacity. All those things that you've already paid for by actually physically having that device that can be converted into a digital economy or a digital good or a transactional element on that device, you can now sell on to those who need that capacity or that throughput nearby.
So the use of the blockchain is to create a metering and payment system?
Correct. So when we sort of, I should back up one little step as well and sort of talk about one challenge, how we got into the blockchain side, because this sort of goes to the heart of what we're trying to do. So in an internet connected world where everything connects to the internet, you often get identified by your IP address, your internet protocol address. In a mesh enabled world where not all the devices would connect to the internet, we had a big challenge at the very start of how do you uniquely identify a device so that you can trust that the person you're talking to and communicating with is who they say they are.
Right.
So we had our developers about 2 years ago come to me and say, John, I think we've solved the problem. I said, well, how did you guys do that? I said, well, you know about Bitcoin, right? And said, yeah, we know about Bitcoin. We've looked at it for a few years. And said, well, there's this new thing called Ethereum, and we think we can use Ethereum to create an Ethereum account on every single mesh node. So in lieu of an IP address, we would create an Ethereum ID, and that would form the basis of its unique identity on the mesh. We
Hmm.
went down that route. That was kind of cool. It gave us this unique identity mechanism. It solved our big pain. But lo and behold, Ethereum as a platform really started to emerge and grow. And as everybody knows in the space now, it's now not just a small little, I don't say research project, but it wasn't just this idea. It has become this big platform. And as we started to talk to our users, and they were kept on coming back to us and said, well, we need some way to be incentivized to be a routing node in the mesh or to share our connectivity. We had built into our core Ethereum. And with that, we said, well, if we have every node that can be functioning as with an Ethereum wallet as part of it, the next logical step would be to say, great, now how do we actually facilitate a transaction from person A to person B? How can we pay them and make sure that transaction or that record is stored and everybody can trust the other? I'm not sure. There's a movie that I watched about a few years ago. I'm not sure if you're a Jason Bourne fan and
Of
watched his
course.
latest movie, but the latest movie starts off with a scene where the hero is out in Albania and he's doing his bare knuckle fighting, and all these guys are behind the scenes in betting left, right, and center on the results of this bare knuckle fight. I came out of the movie and my sons were playing Pokemon Go and the big huge craze that was.
Sure.
And the thought to me is that we have to work in both environments. We have to facilitate the betting to occur in a bare knuckle fight in Albania, just as we can occur to let my son and his brother trade their Pokemon Go characters, sitting in a park with no or limited connectivity. And if you get it wrong, both parties wouldn't like it. The bare knuckle fighters and people who are betting on it wouldn't like it. But I think probably more upsetting would be my sons who didn't get the right Pikachu character in their trade itself. So
Right.
that requires that immutability that blockchain does provide. It does require that I have sold X to you, I have transferred data through you, I have used your device resources, and storing all that information and making sure that it can operate in a trusted environment when there is no trust between parties. That really is what blockchain's been made to do.
Exactly. All right. So I understand the people who are being paid for allowing others to use their internet connectivity, but who's paying into that pool so that those users are paid. Is everybody who's on the mesh network paying into it? And do they all need to have Ethereum wallets? I mean, how's that all work?
That's
How
actually
does
one of
that cash flow work?
yeah, the start of the cash flow really starts with what is happening in the world economy today. We've switched over to this digitized economy where goods and services are being transacted in digital form, be it applications, be it entertainment, be it media of some form. And right now you have most of the Western economies trying to find a way to go out and reach the emerging economy. That's where the consumers are. That's where all the new smartphone adoptions are. If you look at where the growth is coming from, it's coming from India, it's coming from China, it's coming from Indonesia, it's coming from these emerging markets because that's where the consumers are. And 15 years ago, the consumers were not part of the consuming class. They were living in abject poverty, but the economies have advanced so quickly, you now have a lot of companies trying to reach those economies. So take the games or applications market, for example. The average cost of an application for an app install into Southeast Asia is about 70, 75 cents per app install. So if you are a publisher, you're created this latest hot augmented reality game, or you have a magic sword that person can wave around with their device, whatever the game happens to be, you as a publisher need to get that game into the hands of your consumers. That game you are willing to pay the distributors about 70 to 75 cents to get installed. This is a free game. The game probably has some in-app advertising. The game probably has maybe some free-to-play, pay-to-win model attached to it. But those consumers are downloading those games not really in those emerging markets because the cost of that connectivity in that emerging market is so great. So, for example, a study we did recently looked at the cost of connectivity in India and realized that the top 7 free games in India that were running on the Android Play Store would cost a person in about 25 hours of minimum wage work just for the connectivity. So these are free games.
Wow.
But the cost of that connectivity is the expensive part. So we believe that, and we have talked to different app publishers about this, that we believe we can actually distribute applications to these people who do have internet connectivity, that these bridge nodes, these internet connected nodes, and say we can actually give you an app to distribute to somebody who's further down the chain. Every time they do that, they become almost that mini app seller, that mini app store that can now sell an app from onto one person who can then sell it on to the next person, and so on and so on and so on. Every
So
time
in essence, all these coffee shops then become these little mini app stores.
Exactly. One of my favorite stories I love telling is about my one of my earlier trips to Bangladesh. I got talking with her driver, and he has a first generation Samsung phone, a fully functional phone. It did, of course, have a cracked screen, as most phones in emerging markets do, because they get sort of passed down from generation to generation. But he had his phone, and I said, okay, so what do you have on your phone? He was showing me some family photos and some music and some cricket highlights and just the regular things that somebody would have on a phone. I said, so how do you get these apps on your phone? Do you go on Google? And he says to me, well, what Google? Like, you know Google, the big internet company. And he stares at me with a blank stare, and I said, well, where do you get your apps from? Where do you get your content? He says, I understand. And he brings me to this little, small little roadside attraction, a guy who runs a phone repair shop, and he is an internet seller. And what the internet sellers do is you hand over your phone to them, they pop out the SD card, and for about 25 taka, or 18 US cents, they add on your internet for the week. So not direct connection, but they add on the content that you would get from the internet. They add on the cricket highlights, they add on a few games, they add a few songs, and they pass this information from person to person to person. So there's an entire economy that exists of people who are trying to sell and distribute internet connectivity that we take for granted. Once again, these games aren't pay games like you get in the Apple App Store. These are free Android games that provide people with entertainment and joy just as much as they would here, but they just cannot afford the connectivity to download that application the first time.
I would like to take a moment to thank one of our sponsors, the Blockchain Academy. The Blockchain Academy is an educational training firm offering blockchain training for developers and stakeholders. The Blockchain Academy is currently offering the following live courses: Blockchain Security, Hyperledger Developer Workshop, and Ethereum 0 to D app. Visit the Blockchain Academy's website for course outlines and course dates. The Blockchain Academy's courses can be delivered as a company-specific training, tailor-made to fit your organizational needs, delivered both on-site and online. The Blockchain Academy's training is cost-effective, flexible, and can be conducted in a manner that best suits your organizational needs. To learn more about the Blockchain Academy, visit them at www.theblockchainacademy.com. So I understand how that works in a calm emerging market. How does that work though, like in Mexico City where we just had an earthquake, or how does that work in Puerto Rico that's just been devastated by a hurricane? I mean, how would it work in that type of an environment?
If you look at all those emergency situations and the hurricane and devastation from that or from the earthquakes, they've just been horrific. But you also have smaller, more local versions of that. You have school shootings. You have full network disruption during terrorist activities and some of the things that were happening in France last year along there, where people are now being separated from their loved ones without the ability to communicate and connect. The networks just get overloaded with those massive spikes of traffic. For that matter, look at festivals where you have huge influx of people and they just cannot communicate and share at the times when they need to. Sometimes that sharing is just, I'm fine, I'm alive, I'm okay. Other times that might be, send help, I have a massive emergency. In those instances, we know we can help. We know we can make a big lasting difference. We know we can save lives. We know we can actually let those people who have the devices, and most people do have devices, be able to communicate across the mesh. And once again, you are limited by the 100 meters per node, but it has a chance to relay from device to device to device. And sometimes that 100 meters makes all the difference. If you're trapped in a building and you still have your device and you still have that the air and the water you need, you basically need to have that communication go from your device to somebody nearby. We know we can solve that problem.
Interesting. So one of the things that I read about with regards to you is that the idea that the United Nations has deemed that internet connectivity is a basic human right. So can you tell me a little bit more about that?
Sure, and that really goes into the name itself of RightMesh. In the very early days when we started looking at this, we decided to create what we classify almost as our charter of rights. What do we believe in? And we believe in the right to connectivity. We do believe that if you can give a person connectivity, you can change their life outcome. You can bring education to a small school in rural India that didn't have access to information. There's amazing amounts of information about education that is available for free online, yet that doesn't get down to the right person. So when the United Nations made that declaration that the connectivity is a human right, what they're talking about is not just access to the internet as this giant global being, but really the ability to connect to each other and to the information that's most important to them. What's important to you might be a cat video or listening to some of the latest, greatest podcasts and tweets about the worlds of blockchain. May not be as relevant to a person who has to check the local crop forecast otherwise, or the market prices for their crops. Otherwise, they will not be able to feed their family the following week. Access to that kind of information does come down to a matter of life and death.
Right. So you've brought up the example of these roadside stands, 18 cents for connectivity. What is the cost, the actual cost of providing these social connections?
I guess I always say, well, that's the best part. I feel like an infomercial, but the best part about RightMesh is that we have a free software development kit that we are giving out to developers around the world to build applications.
And they can just integrate their existing apps into this
Correct.
using this technology.
So let's say you already have an existing game and you want to play with somebody who's nearby. You can integrate our application in typically about 5 to 6 lines of code, and there'd be obviously some more testing with that, but it really does come down to that simple procedures. Is there a person nearby? Yes. If no, you may still go the internet route. But if there is somebody locally, send information locally. So this software development kit is available for free. the we are able to, by incorporating a cryptocurrency into the mix, allow those that start providing those exit nodes the ability to earn income from that mesh network itself. We believe, and we've been a bit of a fortunate position to do that, that we've been able to create and invest heavily in building this infrastructure up, not because we see it as a massive future profit center, although we do know that once you manage to connect the next billion users, there is money to be made there. But we believe that is the right thing to do. And if we can connect those next billion users and give them that pathway and gateway to the world that's outside of their borders, we have to do it. And it's sort of that. It sounds a little bit cheesy, but in a way we feel that it's our calling, that we must do this effort in bringing connectivity to these markets.
All right. I like this idea. How do you make money?
So we actually will be one of the infrastructure providers ourselves.
Okay.
So in making money, we can provide infrastructure. We will be providing what we classify as super peer architecture, and those super peers will be operating full Ethereum nodes on the edge of the network. So if you do want to connect from a internet selling node, you do need to eventually write that back into a public chain. We will be operating these super peers ourselves. We will also be enabling communities to run those super peers. So if you want to run a super peer and you have fast connectivity, you can operate a super peer as well, and there is opportunities to make a little bit of revenue from that. But really what it comes down to is that as much as we're letting everybody else build applications across the platform, we'll be building applications across the platform as well. So hopefully our team, through building applications, will be able to make money in that regard. We know that there's different applications for everything in the advertising space, everything in the communication space. As we were talking about the app install, if I'm now enabling an internet seller to make 75 cents with every single app install being distributed, as the person who creates the app publishing network, there's opportunities for us to make money from that as well. So we will be players in the ecosystem as everybody else.
All right. So some of the use cases you've given as an example is a way to extend communication in an area that might have a disruption in the standard networks. And I think that's a great use case. And you've also shared a use case with regards to the ability for games to be actually available to areas or to devices that may not have sufficient capability to actually have a direct connection. What are some of the other potential use cases for the application?
Well, let me give you two, one of which is fairly different than the other. So our team right now is over in Mumbai. We are announcing on the 25th, 26th, so today for the listeners, the availability of our software development kit. And we're announcing that from 3 different locations, from live in a conference in Mumbai, India, where we actually are participating in a hackathon. We're announcing it directly from Dubai, and we're announcing it from the World Blockchain Forum in London, and of course with our team over in Vancouver as well. So we're in 4 continents, all doing the same things. But let's talk about Mumbai for a second. So in Mumbai, where you have a very large population, and it's a very large transient population for work, most of whom take the train every single day. We've been talking to some application developers who have train scheduling applications in Mumbai. So that train scheduling application functions much as you would expect, that you as a consumer need to go online every single day and check the schedules. Is the train going to arrive? What time is that train going to arrive? Should I take this route or that route? All those queries go up to the internet to retrieve that information, when in reality, if you go up to retrieve information and I'm standing right next to you, I should just be able
And
to
it's
pull
the same
the
information.
same information. It's a complete waste of energy and resource and time and bandwidth and all those things we're trying to avoid. I can just get it from you. I, as a consumer, am much happier. It gets to me much faster, and it costs me 0. So let's take that train application to the next level. Now, as a passenger on that train, you can be playing games back and forth, and one of the demonstration applications are our team has been building has been a card game, so we can play cards back and forth on a device-to-device communication. But when you get off that train, one of the big things that happens over in Mumbai is all these auto rickshaw riders, people who basically need to get from the train to their office, they scramble around to try to find the most efficient route to go from the train to their office. And they message back and forth with their friends, they try to track people down, they flag people down, and they negotiate almost like an Uber pool type of an example, where they all try to scramble to find one ride that's going in the same direction. We can facilitate all that communication and that really that ride hailing app equivalent for the auto rickshaw in an offline environment. But let's go to the other side of the world. We're involved in a project in northern Canada in a small town called Rigolette, which is on the edge of the Arctic Circle. It's a small town of about 300 homes. They have one internet connection for those 300 homes. We're involved in this project to help connect that city to each other and really to that internet as a whole. So each of those homes and their smartphones that they have within those homes can be connected to each other. And therefore they can now talk back and forth from house to house to house, as well as be able to retrieve information from that one internet connected node. But one of the applications that sort of comes from that is in working closely with the university that we're sort of doing this research with. One of their big challenges is that they have a lot of IoT sensor data that is scattered both around the town and the neighboring hills and valleys of that town. And that sensor data is tracking and helping to report on climate change and the impact on the north. What we're able to do is use our technology to not just run on smartphones, but we can run on IoT devices as well. So if you have a Arduino processor or a Raspberry Pi, and that device runs Java, which is our currently compiled language, we can actually enable that sensor data to pass to passing smartphones, all autonomously without user intervention. And that data from that's being collected by that sensor can now get passed to a smartphone, gets passed to a smartphone, gets passed to a smartphone, gets past the internet, gets past the university where they can actually track and monitor the climate change that they so need to track. So those are two different use cases, completely opposite sides of the world, but both really have the same concept. It's really letting that user who has that underutilized resource, which is their connectivity, or underutilized resource, which is their sensor data, or their storage, or their ability to connect to somebody else, and it lets the user take advantage and yes, monetize that excess resource to their best ability.
Okay, so in these two use cases, are these full-fledged demonstrations, and what's been the size of the number of users in both of those cases?
Both of which are still in the research phase. So it's we have done some demonstration applications, but as I mentioned, the software development kit for our current version of RightMesh was just released yesterday. So we've been building applications with our multi-hop mesh in different markets and testing things out, but they are still in research phase at this point. The capacity of what we think is possible, and this goes back into versus what we have today. What we think is possible is we do believe that we can enable over the next number of years entire communities, not just of 300 people, but of thousands and thousands of people, to be able to communicate across the mesh with intelligent routing that does not require internet connectivity. That's our dream.
And how reliable is the mesh protocol?
Mesh protocol is very reliable. One of the big challenges that our team had to face is how do you make it self-healing? So if I'm forwarding communication through you and you leave the mesh, can I quickly repair and can I track what has been sent through you and then go out and find the next best path? That's a large part of what we built in our mesh technology. It's if you don't do that, it does not become reliable at all. If you send you X amount of bits and those bits don't arrive, obviously you as the receiver are not happy about that. We make sure we track all of that in our system and we make sure it's auditable, that we can actually ensure that the content that you send does get delivered. Of course, it does require density.
Is there a latency aspect that's built into this, though?
There's definite latency. The latency is getting better. Right now, we're at several megabits per second for multiple hops. It's by no means at full LTE speed that you would get of 200
Of
to
course.
300 to 400 megabits per second. But if in practical terms, if you are within that Starbucks I alluded to earlier, or in that web cafe, and you're within 400 to 500 meters of that cafe, you should still be able to stream video to that node 4 or 5 hops away. And
Wow.
that's really one of our big differentiators. We're not trying to just move text back and forth. Text is easy. Moving a geo coordinate across the mesh, that's easy. Moving a "Hi, how are you? I'm fine" type of message, that's pretty easy as well. Moving video files, applications, content, things that are larger, that's where it starts to get really challenging, and that's really where we've been putting our effort. What is possible? I do believe that in a number of years, as we invest more and more in this technology, we will start to see orders of magnitude of speed improvements across multiple hops, and that's really is where our scientists are focusing on delivering that next wave of connectivity. Because if you go back to the fundamental principle, if you and I are sitting in the same university hall, there's no reason why the information I'm sending to you needs to go from my phone to the Wi-Fi router, up to the internet, maybe over to the server in AWS, maybe to the NSA, I'm not sure which, or other government monitoring body, and all the way back down again. That doesn't make sense. It should go from me to you. Going
Right.
from me to you, that's energy efficient, it's faster, and the connectivity cost between me and you is free. That's free unlicensed spectrum. As long as you
Right.
can harness that efficiently, as long as you can make sure that the communication from point A to point B or point C is done securely, privately, it has all the benefits in the world.
Right. So how many hops have you actually been able to chain together, and what was the distance of that?
We did a test outside our office the other day where we had, and this just goes back into where we physically around the building here, but we had 15 people in a row, all chained together. So it's that sort of basically for one side of the street all the way down the other side of the street. Uh, but as you start chaining those things together, yes, you get some efficient distance in that time, and every time there's a new hop, there is some latency that gets added onto it. Part of our secret sauce is that depending on the technologies being used, I can be talking with one person with one type of technology, maybe Wi-Fi, maybe Wi-Fi direct, and I can be talking to somebody else concurrently with a different type of technology. So let's
Right.
say I'm talking to you with Wi-Fi direct and somebody else with Wi-Fi, and we're physically right in the same room. I can actually now be talking to multiple people at once, and therefore the information can be passed through me super efficiently.
Right. Right.
So many other mesh technologies have attempted to do a similar chaining where they have Bluetooth as that switching node itself. So it goes Wi-Fi to
Right.
Bluetooth to Wi-Fi to Bluetooth to Wi-Fi to Bluetooth. But those Bluetooth nodes are now have to be super close together, and Bluetooth is slow. Bluetooth is not a good transport mechanism other than a quick little brief snapshot of information. And we try to do that. But you also go back that within those 4 or 5 hops of connectivity, you go back to that Facebook study where you have 94% of the people within range of a signal. They just cannot afford to use that connectivity or don't see the relevance in that. If we now give that user the ability to earn money from their connectivity, or earn money from just walking around and absorbing sensor data, or walking around and using my device to be a storage node in a IPFS Filecoins type of system, then I can be earning money, and I can be earning that money to then pay you as that person who does have data for access to your network and for access to your connectivity. So
Right. Right.
we don't have to take a whole bunch of connectivity. We don't have to join hundreds of nodes in a row together to have effect. We can actually have massive effect just with 2 people connected together and making their lives better.
So where can a developer where can they download this software development kit?
So our website is on rightmesh.io. That's RIGHT mesh, mesh.io. There is a link to the developers kit. All the information is up on GitHub as well. We have just released our white papers for general release. Those white papers include both a product-based white paper that really describes our mission and our why, and then a much more detailed technical white paper that explains more of the intricacies of how it works and really why it works. We are still growing at this. We are just in inch number one on a mile-long journey. And in that first inch, we've been able to create a lot, but we know that we need to go out to the community and get their feedback on what this next chapter looks like. Because we have a good idea, but if you go out to the market and say, we know better, this is exactly how it works, you're going to create the wrong system. Only by listening to the market did we actually realize that what they wanted was incentivization. If you ask them, this is great, what do you think? This is great, but I need to make sure I get compensated for use of my data.
Exactly.
That's the kind of feedback we need from the consumers. That's the kind of feedback we need from app developers. And that's really where we're at right now.
So are you creating then a crypto coin for RightMesh?
We are.
Is there going to be an ICO in your work, in your future?
In not using the term ICO, because for different reasons, but there will be a token generation event in our future. We are looking
Token
at
generation event. I guess that is the proper way to say it in today's environment.
From our perspective, it is a token. It is a token that is utility to those who need to reach those on the mesh itself, or those who want to compensate others for the resources that they are giving up, or for that matter, if you are creating content yourself, you are creating poetry, you're creating amazing photos, you're doing a video newscast, you can actually create that from your device and upload it across the mesh and now get compensated in tokens for your efforts. We're definitely doing a token generation event, and this really comes out of the need of the users that we've been talking to find a way to be incentivized for that right behavior.
Right. So you alluded to the number of people who are a part of it. You've taken half the development team from left.
Yep.
And you have this CTO who's this genius.
Yep.
So who else is a part of this development team?
So we have a few PhDs on board. We have a few people who are, best way to describe them, as super smart in the field of mesh networking and game theory and the economics of moving data back and forth. We have a chief product officer, Saju Abraham, who's been in the telecom space for a while in value-added services. He's actually very, very interesting background in that he was born and raised in Canada and moved to India at the age of 14, where he went off to do his comp sci degree and then his MBA. And we managed to bring him back here as that bridge between cultures. So we have a fairly large team. We're adding more developers on every single week. I think we had 6 people start in the last 2 to 3 weeks. I just signed a contract before coming onto this podcast with another developer who has a background in blockchain and mesh technologies. We're growing. So if there are more people out there who have backgrounds in mesh technology or distributed systems or decentralized networks or cryptocurrencies and the whole field of that, we are hiring, because token sale or no token sale, we are building this platform. We're taking all of our existing resources and capacity because it's the right thing to do, and we're investing and doubling down and making sure that we can keep on growing as fast as we can.
Now, you've indicated that the SDK is available now. What's next for RightMesh?
So the next few months for RightMesh is really all about getting that SDK into as many users into the hands of as many users as possible. We are going to sort of limit the growth quickly because we want to make sure we can get the support to those developers and make sure that our developers both have time to still program, but also still can take that feedback and find out what works and what doesn't work, and really basically refining the platform up. The next few months is really about us traveling the world, talking to users, talking to partners, talking to app creators, and explaining our story. It's one of the things I should highlight why that's kind of important is that one of the big challenges for mesh technologies in the past is that trying to get a mesh node or mesh router in different markets had proved challenging. Now we have the billions and billions of smartphones that can be those nodes, but also more importantly, we have an app economy and those app users themselves who, by their very existence, can become distributing nodes of the mesh. So if we have one user who installs one application and that application is a mesh-enabled application, and then another user who installs a different application, but it is also a RightMesh enabled application, those users are now functioning nodes that the third user, who it could be one of those first two applications, can now bridge across. So if you have
Right.
two people with an emergency node or emergency application, and everybody else in the entire university only has this most popular game, those two emergency users can actually benefit from the path and the efforts of those previous app developers and those app installs. So
Basically can cross-pollinate itself
exactly.
across the apps.
Yep.
So would I need to like download anything? I mean, it sounds like to me that I don't have to download any special app, but if I download an app that is RightMesh enabled, that then allows for me to be a part of it. And does that automatically then create an Ethereum wallet for me for that particular address?
It does create an Ethereum wallet, but to clarify the term, there are also applications that are wallets themselves. So a better way to look at it is it creates an Ethereum ID for you that can be then used in a wallet itself in the vernacular of the community. But it does create an Ethereum ID upon runtime. So if you are a software developer right now or an application developer, you could go onto the rightmesh.io website, get a developer key. That developer key allows you to start building applications on the network. Your applications then can go out and start using the communication protocols and let your customers share and connect without using the internet.
Fantastic. Well, I want to thank you, John Lyotier, for joining us here on Blockchain 360 and sharing this very interesting story. I had really not been aware of what mesh technology really was, and I think that your integration of mesh technology and Ethereum is a very clever solution for a very difficult problem. And I want to thank you again for being a guest here on Blockchain 360.
My pleasure, anytime.
The Blockchain 360 podcast is produced weekly. Have a question? Want us to interview someone specific? Wish to hear about a particular topic? Let us know. You can email podcast@blockchain360.co or tweet us on Twitter @blockchain360 or at our website blockchain360.co.